Welcome back to this class. Now, let's consider non-metals. Non-metals are elements that ionize by gaining electrons. So now, when non-metals gain electrons, they become negatively charged. So like I explained under my explanation of metals, I said every atom in its free state is always electrically neutral because we have the same number of positively charged protons and the same number of negatively charged electrons. So when the two are combined, they balance each other, so thereby resulting in neutral atom. That is, the overall charge becomes zero. When you add the same number of positive and to the same number of negative, the answer will be zero. And that's why every atom is electrically neutral in their free state. So we have several examples of non-metals. Let's check the periodic table and see where they are located in the periodic table. Now, consider this periodic table. Thank God it's colorful. So now this periodic table is colorful. The metals are the ones that are put in red box, while the non-metals are in blue box, while the metalloids are in yellow box. So you can see that the non-metals occupy group. They are from group group 4, 5, 6, 7, and 8. So the group 4 begins with carbon. So carbon is a non-metal. So other ones are not non-metals. Silicon and germanium are metalloid. Then tin and lead are metals. So if we move away from group 4 to group 5, we have nitrogen and phosphorus. Both are non-metal. Here we have oxygen, sulfur, and selenium, which are also non-metals. So continue like that. We have group 7, which are the halogens. We have fluorine, chlorine, bromine, iodine, and astatine. They are all non-metals. Then finally coming to group 8, which are the noble gases. We have helium, neon, argon, krypton, xenon, and radium. So they are all non-metals. So these are the locations of the non-metals in the periodic table. So there are some of these groups have special name. For instance, group 7 elements are called the halogens or salt formers. Halogens means salt formers. They are the ones that produce salt when they combine with metallic ions. So if we look at the periodic table, we see that examples of elements under that are, look at it, fluorine, chlorine, bromine, iodine, and astatine. They are all halogens. They belong to group 7. Now, the group 8 elements also have their own special name. So the group 8 elements are called noble gases or rare gases or inert gases. So they are generally not reactive. That is, they have stable electronic configuration. Their outermost shell is filled up, so they cannot react with other elements. So let's see examples of them on the periodic table. So if you consider this group, this is group 8. So we have helium as the first, neon as the second, argon, krypton, xenon, and radon. They are all noble gases. Now, have you been wondering why is it that when a non-metal gains electron, it becomes negatively charged? Let's explain what happens. Let's take one element as an example. For example, let's take chlorine as an example. Now, consider the atom of chlorine. This is chlorine atomic structure. You can see that it contains 17 electrons. So this 17 stands for the atomic number of chlorine, which represents the number of protons. Inside the nucleus of chlorine, that means we have 17 protons. And since it is a neutral atom, it must also have 17 electrons revolving around it. Look at the first shell. The first shell contains 2 electrons, which is the maximum it can take. Then we go to the second shell, which is the L shell. The first shell is the K shell. The second shell is the L shell. It takes 8 electrons. And the third shell is the M shell, which takes 7 electrons. So everything all together add up to 17. So we have 17 electrons revolving around it. Now, the proton inside the nucleus is positively charged, while these electrons revolving around it are negatively charged. So now it turns out that we have 17 positively charged protons inside the nucleus and 17 negatively charged electrons outside the nucleus, which balance each other. So now, when we add the same number of positive to the same number of negative, the result, of course, will be 0. So let's do that. So you can see the addition, plus 17 proton minus 17 electron, everything will be 0. So because that is why every atom in their free state, they are always electrically neutral. What now happens when chlorine gains electron? If chlorine gains electron, for instance, chlorine can gain only 1 electron because it belongs to group 7. And group 7 elements only need 1 electron to attain stable electronic configuration. You can see how close they are to the noble gas. So chlorine can gain 1 electron to become stable. Now, when chlorine gains 1 electron, it means we are going to have 18 electrons, but the proton still remains 17. So if we perform the addition of 17 and minus 18, of course, the result will be negative 1. So that means plus 17 minus 18 equal to minus 1. So that means the overall charge that we'll get here is negative 1. That's why every non-metal that gains electron becomes electrically negative. They become negatively charged. Let's see the ion of chlorine, how it happens. So the picture that we have here is chlorine atom that has its complete electrons. So this is chlorine atom. It has 17 electrons. Now, once it gains one more electron, this is the one more electron that it gains. So it becomes chloride ion. And the chloride ion is having 18 electrons, but 17 protons. That means we have more electrons than the proton, which will result in a negative charge. So this is what happens why every non-metal, whenever they undergo ionization, they become negatively charged when they gain electron, because we have more electrons than the proton, which will result in a negative charge. Let's write the ionic equation for chlorine and see how it goes. So this is the ionic equation for chlorine. You can see the addition sign that we have here means that chlorine gains electron, and this is electron symbol. So it's gaining only one electron due to the group that it belongs to. It belongs to group 7, and group 7 need one electron to complete. So, and once it gains one electron, it becomes Cl minus, which is chloride ion or chlorine ion. So we can represent the general ionic equation for all non-metal as follows. So let me interpret this. X plus n e raised to power minus to give x n minus. So x represents a general non-metal. It can be chlorine, it can be fluorine, it can even be nitrogen. Now, n represents the number of electrons that this non-metal can gain. And this depends on the group that the non-metal belongs to. If it is in group 7 can gain only 1 to complete, to have stable electronic configuration. If it's group 6, they can gain 2 to complete 8 electrons. If it is group 5, they can gain 3. If it is group 4, they can gain 4. So to have stable electronic configuration. So let's apply this to other non-metallic elements. Before I go there, this equation can be rewritten in another form. So don't get confused if you see it in textbook like this. So this new equation is the same as the one above. It's just by moving the electron to the other side. So that is the only thing that is different here. We move the n electrons to the other side to have it in the other way. So don't get confused. They are just the same thing. So let us apply this ionic equation to write the ionic equation of other non-metals. So let's take, for instance, fluorine. First thing we need to consider is which group does chlorine belong to. So in the periodic table, fluorine also belongs to group 7. So this is fluorine here. All of these elements that we have here, they belongs to group 7. So they need just one electron to have stable electronic configuration. So their ionic equation goes thus. So consider each one of these. Fluorine can gain one electron to become the fluoride ion, and chlorine can gain one electron to become the chloride ion, which is Cl minus. And bromine can also gain one electron to become the bromide ion, Br minus. And also iodine can gain one electron to become the iodide ion, I minus. So let's see other elements from other groups. Let's see group 6 element, for instance, which contains oxygen and sulfur. Consider oxygen, sulfur, and selenium. They are capable of gaining 2 electrons because they belong to group 6. Group 6 needs 2 electrons to complete 8 electrons. So Se, starting from oxygen, O plus 2E minus to give us O2 minus. So this is the oxide ion, that is oxygen ion. Then sulfur can gain 2 as well to become S2 minus. And then selenium can also gain 2 to become Se2 minus. Then other elements in other groups too also ionize the same way. Then let's consider group 5 elements, something like nitrogen and phosphorus. So these elements, they belong to group 5, nitrogen and phosphorus. Now, nitrogen is capable of gaining 3 electrons because we need 3 in addition to 5 to complete 8 electrons. So now, nitrogen can gain 3 to become nitrogen ion as nitride ion, N3 minus. So the same thing as phosphorus, it can also gain 3 electrons to become the phosphide ion, P3 minus. So and that, we can follow this pattern to write the ionic equation of other elements too, other non-metals. Thank you.